Lab 1 Charged Tapes. Introduction. The purpose of this lab is to observe charge and determine excess charge. And by doing this, we are using Coulomb's law, the electric field formula, force and electric field formula, and the force of gravity. The Coulomb's law is used to look at two different types of charges with a specific distance away from each other with the constant, Coulomb's constant, and it determines a force. The electric field formula is very similar to Coulomb's law, but it uses only one charge. And then we can combine the electric field formula with the charge to find a force, and then the force that we are using is gravity. For the procedure, we had to take two pieces of tape with handles. One would be the base and one would be the U-tape. We'd place the base tape on a surface and the U-tape over that. We'd rip the top tape off the base to charge it, and then we test the charge on a positively charged pen and a neutral surface to make sure it was a negatively charged tape. And then we created two charged tapes and put one on top of the other, with the top tape being connected to two books, and then the bottom tape we were just holding to at the bottom of the top tape. And then we recorded the distance between the two tapes when the top tape started to lift up and it seemed to float. Our assumptions: air resistance is negligible, and the tape is treated as point charges. The U-tape has its charge evenly distributed on its surface, and they contain the same charge. The sum of charge will be equal to the total charge, and the length of tape is used to determine the mass. Our measurements and data for the mass of tape: we did length times kilograms over mass and gravity to find our mass. And then with surface area, we did length times width of our tape, and then the number of atoms. We used that surface area and we divided it by an angstrom to find the atoms. And then for our measurements, we used the electric field formula for force, and we moved the equation around to get it to equal Q instead of the force, which resulted in the coulombs, which is what we were looking for. Excess electrons, we did charge tape over electron charge. We found the charge tape above, and then electron charge is just the one electron. And the ratio of excess electrons to atoms, we used the equation above and then the equation on the slide previous. Here is my Glowscript code, where we had constants, and then we had our forces, which was gravity and the electric field. And then with the Glowscript code, we were finding the charge on tape, the number of electrons on tape, the ratio of electrons to atoms, the number of atoms on tape, and the number of deficient electrons. Here is the results from that Glowscript. They match the numbers that we found very similarly, and the picture shown on the right shows the direction of gravity and the electric force field with the two tapes. So what if? If the charges on protons and electrons were swapped, then two tapes are held together, then they would still repel each other because both charged tapes would be positively charged, and the same would go for the charged pen and tape that were brought to each other. The pen would be negatively charged and the tape would be positively charged, which means they would still attract each other. And why? The charged tapes must be handled as little as possible because handling them resulted in some of the excess electrons to escape. This is because electrons that move to a more neutral object will create a more neutral interaction. This is so that the tapes will keep their charge pattern.